Dan Alford, Arc Specialties, reporting from McCormick Center in Chicago, Fabtech 2025. I'm here with an old friend, Paul Chang.
How do you do?
Doing well.
Thank you for your time.
So Paul and I have known each other for 10, 15 years, something like that?
I was at your shop in 2019.
And you got a clever invention here, but I never saw anything tangible. You showed me photographs, you showed me some diagrams. Now you got a machine.
Well, when we first met, I had a concept and one patent.
Right.
And I understand your reluctance. It's a big claim. But then, since then, I've continued to file the patents, and now we've got over 10 plus.
I don't care about patents.
Yeah, okay.
I care about machines.
Okay.
And what you're doing, this is amazing. So you're welding zirconium solid to a 0.3 millimeter thin wall tube.
Yep. This is demo number 2. We built demo number 1. That's for 4-inch and 6-inch, schedule 40, schedule 80.
Right.
But this one, because it's smaller, it went ahead faster. So the students, I'm so pleased. You know, the first 40 joints, nothing. Couldn't join. Everybody was kind of expect maybe it doesn't work. But then joint 41. You should have seen them. They all looked back. Paul,
it worked.
We have a weld. And that look made everything worthwhile. It's goosebumps.
You got to describe your technology, but you also ought to give credit. Who are these students? Who are you working with?
University of Waterloo, Dr. Adrian Gerlich,
Yeah.
Mark, and a few of the other PhD students. And then Sources Technology is the contractor. Saman, they just left this morning.
He's a machine builder.
Yes, sir. And so they're smart people, but we have no pedigree. So we're not able to reach the big cheese of the big companies. Because they say, FuseRing, who the heck are you? Click. So we have a slower time reaching people to say this works and this makes sense.
Okay, I've been doing friction welding since the 70s. And so this has some similarities, but it's unique. It truly is a new welding process. Describe it to me.
There's a couple of new science involved, Dan, because now we are joining metal at below melting.
So this is a solid state diffusion bond.
Absolutely. The difference here is we're heating one part, the rod, on this side, but we're transferring it into the collet.
So this is a preheated joint, but we're not just pressing them together, are you?
We're pushing at the right temperature and just turning slightly.
And that's the magic.
Yes, sir. Now, there's no PhD studies anywhere in the world, so I welcome students. If you want to do PhD, you'll be cited for years. The difference, I believe, is when you push today's technology, everybody stops. And friction, you push, you stop. What I think is, at the right temperature you touch, crystals wants to grow right away. But by shearing, you break the crystals continuously as they form. So that's why the grain structure is fine grain, right through.
Interesting.
Yep.
But you're only heating one side of the joint. I thought that was clever.
It is new science also. It is heat transfer.
Because you simply can't heat a thin wall tube without melting.
There's different geometries on that. We can make it even flat when it comes out. We can make this flat on the inside of the weld so it'll never see fluid. That's the difference. But the lathe we have is 25 years old, so we're not that accurate. So we're looking for getting another second-hand, better lathe to make a better profile.
Well, outstanding. I'm impressed. I've seen the welds. I've seen some of the testing. I think you've got something unique here.
Yes, sir.
And I think your timing is right, because what are these for?
Nuclear. SMR.
Small modular reactors.
Yes, sir.
There's 60 companies in America, and hopefully at least a few of them are listening to our podcast today, but I think this could be an enabling technology in the next generation of small modular reactors.
Yes, sir. The thing is, nobody knows exactly what is the failure rate of these fuel rods. From the published data I can find, it is 0.01%. But for a million rods, that is still 1,000 welds that fail. This is repeatable, repetitive, zero failure.
But that's not to say you're limited to zirconium or limited to small parts, or...
We have questions from the aerospace for the higher speed stuff, the higher temperature stuff, more exotic.
Ah,
But we're not quite ready to test. I know we can do it, but that's,
yeah.
so come help. We're business friendly.
Well, very good. Can we see it run?
Absolutely.
So describe what's happening.
So right now it's going in the induction coil. It's going to be heated up to its temperature. We're doing just a little bit of pre-purge to get that oxygen away from the interface. It's heating up and it's about to press the metals together, turn and smear them. That'll break up the oxides, that'll break up all the imperfections, refine the crystal structure and smear the metal together. So that joint was done the second that turn was finished. So in an automation setting, it would already be doing the next one. This is just for safety. So there you go, watch it coming out, it's done. We're ready for the next one.
That's impressive. That's a new welding process. In
Yes,
my
sir.
lifetime, they've only come up with a handful of new welding processes, and I'm going to credit you with one of them.
Thank you very much. I thank you for your time and interest. But there's one other thing I'd like to mention. We can weld in space.
Yeah, there's only a few processes that work. Electron beam, resistance welding, and
Solid state.
solid state.
Electron beam, laser, and all the other high energy has problems they can't scale.
Right.
And in 50 plus years, this is about as big as they've ever done.
All right.
We can scale easy. Why? The audience, why can we weld in space ultra safe, vacuum, gravity, neutral?
The vacuum will be an advantage to you.
Right, and it's gravity neutral because there's no splatter.
No spatter. Huh?
Right, we stay in one piece. It's like a putty.
Well, you still need to solve a few problems on the Earth before you launch, but
Right, but I'm trying to tell NASA and ESA, can be done.
very good. Well, you told me about this for years, and now you've done it. Congratulations.
Thank you so much.